Hi friends, today we are going to start with our continuation of advanced calculus, and today we are going to discuss about the triangle equality in complex numbers. So before going into the calculus part, first let's understand what exactly the triangular equality in the normal simple triangle form. Then we will come into the in the calculus one. First of all, what we are going to do, let me just write over here what is the what exactly the what we want to prove and how we will do that. So in the previous session, you remember that we represent this is the we represent this is a symbol. So I have Z1. So Z1 belongs to. So you remember we have this symbol is for belongs to, and this is for the complex number. So here Z1 and another one is the Z2. I am just considering here. So these both Z1 and Z2 belongs to a complex number. So as I told you, today we are going to discuss about the complex numbers. Okay, so now what we need to do, what happened, what exactly the triangle equality in the complex number. So if we have Z1 and Z2 are two complex number, so I am just taking here Z1 and another one we have here Z2. These are the two complex numbers. So this says that this is equal to Z1 plus Z2. So but we need to prove it. So first of all, we'll prove it with the help of a triangle. How we will do that? So how we can do that? We can just consider this one. So this is a number system. Here we will consider that this is the real part. Real, I'm considering it's a real Z. We are representing here, and here we have an imaginary part. So this one in an imaginary part, imaginary Z I'm considering. So I'm assuming somewhere this point where we have an point A, and somewhere this one we have a point B. Okay, so this is our origin. So we'll consider this one is an origin point. So I'm just draw it with some other pen so that it's clear. So this is my origin. What we will do, we'll just draw a line over here. So this line represents, I am assuming this line represents Z1, and another line, this line represents Z2. Okay, so what we have here, so when we draw here a parallelogram, so let's draw a parallelogram over here. So this is a parallelogram. So another line will draw parallel to this one. So this is a parallelogram. So in the parallelogram, this value is equal to this one. So this value is equal to Z2. So let me just change the pen over here. This value is Z2 here, and this value is equal to this one. So this one is the Z1. So now we will draw one perpendicular from this side. So this is the one perpendicular here. So the value of this one, so if we will come into the the value of this line. So if I am assuming this is the Z1 and this is the OZ. So how we will represent this? OZ is equal to Z1 plus Z2. So what is the value of is OZ? This Z1 plus Z2. Okay, and we can draw another diagonal over here. So this is our another diagonal. So we'll draw this another diagonal here. So what is the value of this one? So the value of this one is Z1 minus Z2. So this one is Z1 minus Z2. Okay, so let's come and we'll just prove this one how in the triangle of inequality how it is. So as I told you, if we'll take an example of this triangle. So let me just take an example. So what we are going to do, we will having a triangle A, O and Z. So in triangle O, A, Z. So in triangle OAZ we have this one. So we have this modulus of Z1 plus Z2. So how we are saying that this value this Z1 and Z2 is greater than or equal to the Z1 and Z2 as per the as you remember as per the normal triangle inequality law. We have the two sides, and the sum of the two sides is always greater than or equal to the third side. So the third side will be, as the third side we have this one OZ. So this is equal to Z1 plus Z2 and this one. So this is the basically in case of the complex number, how we will be thinking about the triangle inequality. So same way we have here another thing. So we have Z1 minus Z2. So this is less than equal to, uh, we we have Z1 minus Z1 minus Z2. Okay, so this is the another the second form of basically second equation of the inequality. We can also prove with the help of this one. Okay, so but we are in the calculus one. So what we need to do? We need to start how we can prove this with the help of the calculus. So we'll just come into the calculus one and we'll prove the formula how we can prove that. Okay, so I'm just erasing the okay, let me just take another page so that we can just start with this one. Okay, let me I'm just okay, I'll just clean this this part, so that we can just start with this another formula. Okay, so now we will come into the calculus. So how we will solve this one. So in the calculus, let me change the color. We'll take a simple one. Okay, so now we have here Z1 and Z2. Now what we discuss, we have here Z1. So here, oh sorry, let me write it. So we have Z1 plus Z2. This is equal to less than equal to Z1 plus Z2. Okay, so that is the thing we are going to prove. So first of all, what we will do, as you know, we will square in both the sides. So we'll take this one. First of all, what we will do, we'll take the left hand side. We'll take the right hand side. We'll take the right hand side, RHS. So RHS is equal to, this one is equal to Z1 plus Z2. So what we will do, we'll do the square of this one. So uh, when we have a formula over here, so the square of this one, and when we break this one, so for which it is equal to, this one is equal to Z1 plus Z2. uh, okay, let me just write it Z like this so that it's easy to represent, because otherwise it look like 2. Okay, so we have here Z1 and Z2. Now, and another one is, we have here Z1 plus Z2, and this one is the bar conjugate of this one. So the form, why we are writing this one, so because the formula is, if we have Z and Z conjugate, okay, this is equal to the Z square. Okay, so the same formula that we have applied over here. Now what we will do, we will just multiply this one. So for when we just multiply this one, so this is multiplied to this one, then this will multiply to this one, then we will multiply this one, then next to this one. So we'll come here Z1 into Z1 into uh, Z1 bar. So okay, before this one, before the multiplication, let me just break this one. So we have another property over here. So if we have Z and Z1 and Z2 bar, so or we have addition over here, so we can represent its Z1 bar plus Z2 bar. Okay, so this is the another property. So what we are going to do here, we will split this one. We have one is Z1, so we'll just represent this one is Z1 plus another is Z2, and then we'll split Z1 bar plus Z2 bar. Okay, now we will just as we'll discuss, we'll multiply this one, cross multiply this one. So we have here Z1 and Z1 bar, then we will multiply to this one Z1 and Z2 bar, then we have Z2 and Z1 bar, then we have Z2 and Z2 bar. Okay, so now we'll come to here. So again, basically in here we should know about the complex multiplication and how we'll complete how we'll do that. So as we know, we have here if we have Z1 and Z2 bar. So how we can represent this one? So this will be represented as Z1 square. Okay, so we'll replace this one. So we have Z1 Z1 square, then we have Z1 and Z2 bar plus Z2 bar, Z2 and Z1 bar, and here we'll convert into Z2 square. Okay, now what we need to do, will come over here and we'll do one more formula over here. So what exactly the formula over here is, we have Z1 square. Now what happened, we can write this statement like this one. We'll write it as Z we have here Z2 and Z1, so we can represent it as an 2 real, uh, twice of real, and this is a set of Z1 comma Z2, and here we have Z2 square. Okay, so now basically why we have written this. So as there is one more formula, Z and Z bar is equal to this is equal to twice of the real number of Z1. Okay, and the one more thing I just want to be just tell you. So when we have this twice of real numbers, so twice of this real numbers of Z, so this value is greater than or equal to minus Z, uh, and it's less than equal to Z. So now we will apply this formula. So as we will apply, this value is greater, so we will just consider this one. So what happened, if you will remember, we will have, so when we replace this value real to this Z1, so what happened, this entire the equal to symbol will be changed into, because this value will always be the greater than. So how we can represent this one is the Z1 ka square plus we have Z2 square, and we are going to replace this value. So we will replace this value is a twice of, it's a twice of Z1 plus Z2. Okay, twice of Z1 plus sorry, twice of Z1 and Z1 and Z2, because there is no symbol, there's no plus here. So it's a twice of Z1 and Z2. It's a multiplication symbol over here. So till this point I think everything is clear. Okay, so now I will just come and tell one more thing here. So if you will see here the formula that we have chosen, so let me, okay, so now if you will see here, when we split this one, so now when we split this one, so how we can split, so I have the space crunch, so I'm just splitting this statement. So how we can split this statement, this statement can be written as twice of Z1 and Z2. We can write it like this, and this is the bar. Okay, and sorry, Z and Z2 will be here in the bar. Okay, because here we have the Z2 bar will be there. So now this if you will see the complete statement, so how we can write this statement, we can write this statement as the square of it's an absolute of Z1 plus absolute of Z2, and it's a whole square. So if you will see the formula, whatever the result we have, Z1 plus Z2, Z2 whole square is less than equal to this. Now if you will see, if we will take the square root of this one, this value is we can remove this value. Now the final result, it becomes to this one, our original statement that we need to prove. So hence what we say here, so basically we can say with the help of the calculus, we can solve the modulus of Z1 plus Z2 is less than equal to the sum of the absolute of Z1 plus absolute of the Z2. Okay, thanks. I think this formula is clear. In the next sessions we will discuss about its problem sets and how we are going to use in few future sessions we'll discuss how we can convert it into the programming concepts and all. But as of now I'm just coming into the basics, basics of the calculus one. So then gradually we'll move to the programming as well in this. Okay, yeah, thank you for watching.